All right. So at this point, we're down to 2 units left. They are both on circles. So this will be very different from what we've been doing. What we've been doing, a lot of stuff where we have formulas and the like. Not a lot of formulas in this. Okay? For some of you, where you're like, I'm not good at memorizing formulas. That's a good thing. The flip side is there's a lot of vocabulary. Okay? And you have to know the vocabulary. In fact, there will be a section on our next test where I'll have a diagram that has all kinds of stuff drawn in it, and I'll say, what do you call this line? What do you call this segment? What do you call this piece of a circle? And you have to tell me the names. Okay, I almost never do that, but on this test, I will. All right? So, here are some terms that you need to know. First of all, a chord, it's spelled the same way as a chord in music is spelled, is a segment that has its endpoints on a circle. So if we look down at this, this is an example of a chord. Both endpoints have to be on the circle. Not inside the circle, not outside. They have to be on the circle. Okay? A secant, and some people say secant. I think those are the same people who say pecan instead of pecan, which gives me the willies whenever someone does that. Is a line that intersects a circle at 2 points. This is a secant. Notice what's inside of the secant from here to here. What is that? If I just go from here to here, no, it's not a diameter. Thank you for playing. We have some lovely parting gifts for you. If I just go from here to here, sorry, it's what I always used to say on game shows when someone lost. They're like, oh, I'm sorry, but we have some lovely parting gifts for you, which was usually, the home version of the game, so they could relive their, their failure. Exactly. All right. What is this from here to here? Yeah, what kind of segment that we just went over? It's a what? It's a chord. Okay? Every secant contains a chord. If you've got a secant, there's a chord in the middle of it. Okay? And then another term that is new for you, and not today, but on another day, I'll explain why it has the same name as one of our trig functions. This is called a tangent. A tangent is a line in the plane of the circle that intersects the circle in exactly 1 point. That point is called the point of tangency. Now, you may be wondering, why do they say all these words? Why do they have to say in the plane of the circle? Well, here's why. If I have a line like this that's going through the circle like that, that's not tangent. It has to be on the same plane like this in order to be a tangent. Okay? So it's got to be in the same plane. It can't come from outside of the plane like it's some sort of archery target or something. And then this point is the point of tangency. So, one of the things that will be on your assignment tonight will be a problem like this. I think there's 2 or 3 like this, where it says identify each line or segment that intersects circle P. When they say identify, they mean write its name and tell what it is. Okay? And you can start wherever you like. So for example, in this one, if I start with segment QR, what is segment QR? It's a chord. What about segment QP? It's a radius. Are there other radii? All right, let's be lazy and get them all done at once then. What are the other radii in this picture? SP, yep. What's the last one? PT. These are all radii. All right, what about line M? I heard an answer, but it wasn't the right one. Secant, yes. Yeah, that's a secant. Now I heard someone say a diameter. If I want to make it a diameter, I've got to make it a segment instead of a line, and that's really the only difference. So this is a diameter. And what else is it? I think someone said it, but they said it quietly. What? It's a chord. A diameter is always a chord because its endpoints are on the circle. All right, what about line L? What is it? It's a tangent. So you got to know the vocabulary, or a lot of things aren't going to make sense in this unit. All right, that's page 1. Everybody ready to go to page 2? All right. So we've talked about congruent objects all throughout the year. Remember, to be congruent, objects had to have 2 qualities. Can anyone tell me both of the qualities that you have to have in order to be congruent? I'll give you a hint. It all starts with S. Nope. Someone said same size and 2 more S words. No, it's not same side interior. Same size, same shape. You guys are cracking me up today. It has to be the same size and the same shape. Now, with circles, do we have to worry about them being different shapes? No, if you've got 2 circles, they're always the same shape. Whereas with triangles, you can have 2 triangles that are very different shapes, right? So, in order to make them be the same size, well, if they have the same size radii, they're going to be the same size circles. So 2 circles are congruent if and only if they have congruent radii. That means it works both ways. That means if you know you've got congruent radii, you've got congruent circles. If you know you have congruent circles, you have congruent radii. So circle A and circle B can only be congruent if segment AR and segment BS are the same size. If they're not, then they're not congruent. Concentric circles. We don't do a lot with concentric circles, but it does come up from time to time. All right, Spanish fans. So this literally means with centers that are the same. Concentric circles are circles in the same plane with the same center. Again, back to the idea of that archery target, right? When you have an archery target, those are all concentric circles. They're all in the same plane, and they all are with the same center. Now, not like an archery target. Two coplanar circles that intersect at exactly one point are called tangent circles. Tangent means they just have one point in common. If something is tangent to something else, they just have one point in common. So here we have a picture of two internally tangent circles because one circle is inside the other one. Here we have the figure eight or the snowman or whatever you want to call this. These are externally tangent circles. Again, these don't come up a ton, but they are terms that you need to be familiar with. All right, now we get into the theorem part of this. You having fun, Peter? All right, so if a line is tangent to a circle, so when we say a line is tangent to a circle, that means that the line is a tangent line. That's what it means. Then it is perpendicular to the radius drawn to the point of tangency. So if I've got a circle and I've got a tangent line and then I draw in the radius, it always makes a right angle. You don't need to draw this, but let me just show you real quickly. You could do this anywhere. I'm going to make a line. If I make it to where it's tangent to the circle, and then I draw from the center to there, it always makes a right angle every single time. I mean, you don't even have to be particularly careful about drawing it. That's always going to make a right angle. Because of that, we can do a whole bunch of different kind of problems. Here's one type. In each diagram, segment KH and segment KD are tangent to circle C. They want us to find the measure of angle K. You need to know two things in order to be able to do these problems. First thing is what we just learned. When you have a line that's tangent to a circle, God bless you, then any radius drawn to the point of tangency will make a right angle. So that's a right angle, and that's a right angle. Every single time. The second thing you need to know is what do the angles in a quadrilateral add up to? And no, it's not 180. It's 360. The angles in a quadrilateral always add up to 360. So what I know here is that 138 plus 90 plus 90 plus the measure of angle K has to be 360. Let's see, that's 180, so this is 180, 280, 318. So subtracting, I get the measure of angle K is 42. We can also do that as an algebra problem. Here I've got two segments from a point outside the circle that are tangent to the circle. So the radius drawn to the point of tangency always makes a right angle. On these problems, every now and then it's going to look like the right angle is in the center of the circle. It never, ever, ever is. The right angle is always where the tangent meets the radius. So same idea on this one. I know that 3x plus 90 plus 90 plus 7x is 360. All right, well that's going to be 10x plus 180 is 360. Subtracting, we have 10x is 180. Divide by 10 and we have x is 18. So the measure of angle K is 3 times 18 is 54 degrees. Before we move on to the last bit, I want you to notice something. In this one, 3x plus 7x gives me what? 10x. And what is 10x equal to? 180. And if I take 138 and 42, that's 180 also. It's slightly faster if you know these two angles are always going to add up to 180. Because these two angles already add up to 180, and total they add up to 360. All right, so that leaves 180 for these two. All right, this also involves tangent segments. If two segments are tangent to a circle from the same exterior point, then those two segments are congruent to one another. So whether I go to this side of the circle or this side of the circle, if I'm drawing to the point of tangency, those two have got to be the same. I had a student years ago who called this the ice cream cone problem. I was like, what the heck are you talking about? He said, well, if you have a scoop of ice cream on top of this cone, if this side is too short, your ice cream's going to roll off, and that would be sad. And I'm like, if that helps you remember it, great. Personally, I just look at it and go, yeah, those look the same size to me. So, for this problem, we know that these two segments are congruent to one another because they're both tangent segments from a point outside the circle to the point of tangency. So that means that x over 4 is equal to x minus 6.3. There are lots of ways you can solve this problem from here. I'm always looking for the easiest way to do it, and I think the easiest thing to do is get rid of the fraction immediately by multiplying both sides by 4. When we do that, we're going to have 4 over 4, which is what? No, 4 over 4 is not 16. 4 over 4 is 1. So I just have 1x, and here I need to distribute the 4. So that'll be 4x, and let's see, 6.3 times 4. There's one place after the decimal, so that's going to be minus 25.2. Subtract 4x from both sides, and I get negative 3x is equal to negative 25.2. We'll divide 3 into 25.2. So it's going to go 8 times. Subtracting, that's 1, bring down the 2. 3 goes into 12 4 times. So x is 8.4. And then be sure to answer the question. They ask for the length of HG. So HG is going to be 8.4 over 4, which is 2.1. All right, you have a little less than 15 minutes still left. I will expect that you're working on your assignment, which is in the book.